Good morning children, welcome back. In the previous video we have seen about the Newton and the Kepler's law, and we have seen the capital G, that is universal gravitational constant. And now we are going to see about the small g, okay, that is acceleration due to gravity. Now what is difference between the Earth's gravitational constant and acceleration due to gravity? So, acceleration due to gravity is defined as uniform acceleration produced in a freely falling body due to gravitational force of the earth. That is acceleration due to gravity. What is the value of it? Acceleration due to gravity, small g, is equal to 9.8 meter per second square, or 980 centimeter per second square. This is very important value you have to remember, that is 9.8 meter per second square. Okay, so how to calculate now? Calculation of acceleration due to gravity. Suppose a body of mass small m is placed on the earth of mass capital M and radius is capital R. You can see the figure over there. Okay, there is a object placed on the surface of the earth, that it has a mass of small m and the mass of earth is taken capital M. Now according to Newton's universal law of gravitation, we have formed this formula in the previous video, that is force exerted F is equal to G capital M into small m upon R square, capital R square. This force exerted by the earth produces an acceleration on the body. Therefore, F is equal to mg. In the acceleration, the formula of force is what? Mass into acceleration. So now in the place of acceleration, what we are going to replace A with G, that is acceleration due to gravity. Why we are going to replace it? Because now the acceleration is acting due to gravitational force, and therefore we will remove the A from it and will take the small g. From the two equations now we have, that is we are going to substitute mg in the place of F, and therefore mg is equal to capital G capital M into M upon capital R square, or small g is equal to gm upon R square. Okay, here when you take the m on the right side, the small m is going to cancel, and therefore there is no small m written over in the last equation. Okay, next, acceleration due to gravity on the earth is calculated as follows. The mass of the earth is 6 into 10 raised to 24 kg. Radius of the earth is 6.4 into 10 raised to 6 meter. So the gravitational constant 6.67 into 10 raised to minus 11 Newton meter square per kg square. And the formula we have calculated earlier, that is G is equal to capital G into capital M upon R square. We have to substitute these values, and when we substitute these values in it, we get the answer small g is equal to 9.8 meter per second square. Okay, so now did you get how this value came? Okay, we have considered the mass of the earth, the radius of the earth, and the gravitational constant. Okay, next, variation of acceleration due to gravity. So what are the variations coming in it? Acceleration due to gravity decreases with the altitude. Means what? If you go higher and higher, then the acceleration due to gravity will decrease. So the formula is what? G, that is gravitational constant, is equal to capital G into M upon R square. And when it decreases, when we go up and up, the height is going to increase, so the radius will also increase. Therefore the R plus H, just R plus H is added over there. Why H is added over there? Because as we go higher and higher, the area what we have to calculate, it will increase the radius, so R plus H is taken in spite of only r. Next, acceleration due to gravity decreases with the depth. Okay, depth means what? Now we are going inside the earth. So what we are going to do? We will minus that h from radius. Okay, because we are not going up from the earth. We are coming down in the earth. So the radius will decrease. What we have to calculate. So r minus h is taken. Next, acceleration due to gravity is greater at the poles and less at the equator. Why it is so? Because the earth is elliptical, correct? If it is it is oval in shape, then what will happen? The poles will be at the extreme end. Therefore, the acceleration will be more at the poles and less at the equator. Earth is slightly flattened at the poles and bulging at the equator. Therefore, the radius of the earth at the poles is 21 km, less than that at the equator. Therefore, radius at the poles will be less than the radius at the equator. Therefore, from above equations, capital G and capital M being the same, and small g is inversely proportional to the square of the radius. That is, if the radius increases, the gravitational force will decrease, and if the radius decreases, the gravitational force will increase. Okay, so the values of gravitational force are given over there. Okay, the average value we use to calculate is g is equal to 9.8 meter per second square. So under the influence of g, we have studied this laws of motion, correct? That is v is equal to u plus at, then s is equal to ut plus half at square, then v square is equal to u square plus 2as, correct? So what we are going to do now? We are going to replace some initials because of the influence of gravitation. So let a body be thrown vertically down with initial velocity u. The u is kept same. Final velocity is also taken same, that is v. Okay, u is equal to initial velocity, v is equal to final velocity. Okay, then after the time t is also kept same. Let h be the height, that is vertical distance. So s is replaced by h and covered by the body, and g with the acceleration due to gravity, and then a is replaced by g. Okay, now in first case, then equations of motion are what? There is no change in there. Okay, so v is equal to u plus at was your initial first equation. After influence of gravitation, what will happen? V is equal to u plus gt. A is replaced by g. Then s is equal to ut plus half at square was your initial equation. Now what will happen? H is the distance taken over here. So h is equal to ut plus half gt square. A is replaced by g again. Next is v square is equal to u square plus 2gh. Okay, that is v square is equal to u square plus 2as. Okay, a is replaced by g, s is replaced by h. Now, when a body is dropped freely, the equations of motion will be: if we are dropping something from above, we are not applying any force in at the initial stage, so u will be 0. Okay, what we are doing? The condition is given that body is dropped freely, means at the initial stage nothing force is there, that is u is equal to 0. Therefore first equation will be v is equal to gt, because u, that is 0 plus gt means what? 0 has no value, so v is equal to gt. Next, h is equal to half gt square, because 0 into t 0 again, so half gt square. Next is v square is equal to 2gh, because again 0 square means what? 0. Therefore v square is equal to 2gh. Okay, now when a body is thrown vertically upward, okay, now what we are doing? We are throwing a ball upwards. Okay, Now for throwing, what we are doing, we are applying force at the initial stage, correct? So u will be there now. Okay, now initial force will be there, and next the final velocity will not be there. That is, u will be there and v will not be there now. Okay, so v will be 0 now. So v is equal to u minus gt. Why minus gt? Because we are acting against gravitational force, correct? The ball is going against the gravitational force. If it is coming down, then it will be plus gt. But now what we are doing? We are going against the gravitational force. So now it will be minus g. Next, h is equal to ut minus half gt square. Again, because we are going against the motion, against the gravitational force. Next, v square is equal to u square minus 2gh. Again minus 2gh, because we are going against the gravitational force. Again I am repeating again and again. When we go against gravitational force, the sign will be minus, or the numerical or the value will be again always minus, negative. Okay. So here what I was telling is what? The Cartesian sign convention. Cartesian sign convention means what? You have seen the graph plotting in the mathematics, correct? In mathematics, what it was there? When you plot a graph, the right side there is positive, left side there is negative, up it is positive and down it is negative, correct? Same Cartesian system is followed for this motion also. The physical quantities having vertically upward motion are assigned the positive values. Okay, all the quantities which are assigned in the upward motion, it will be positive. On the other hand, physical quantities having vertically downward motion, it will be negative values. The acceleration due to gravity always acts in a downward direction and hence taken negative. The acceleration due to gravity is always in the downward direction, so it is going to take always negative. So here are the tips to solve the numerical problems. G is always taken negative. When a body is dropped freely, its initial velocity will be u is equal to 0. Why? Because when we are freely just throwing, we are not throwing it or we are not pushing it. We are just dropping it freely. Means what? We are not applying any force at the initial stage. So the initial velocity will be 0. When the body is thrown vertically upward, now what we are doing? We are throwing a body upwards. So the final velocity will become 0 at a maximum height. Means what? When you throw something up, what is going to happen? The force is going to end at a maximum height and then it will start coming down. So that is v is equal to 0. Final velocity will be 0. The time taken by a body to rise to highest point is equal to the time takes to fall from the same height. That is, when we throw something up, what time it takes to go up is the same time which it takes to come down. Okay, means what? I'll give you example. If I throw a ball from up, if it takes 2 seconds to go up, then it will take 2 seconds to come down. That is known as the time taken by body to rise to the highest point is equal to the time takes to fall from the same height. Okay. Next is the mass of the body is quantity of matter contained in it. Now here we have come across a concept of mass and the weight. Okay, what is mass and what is weight? We have the two terms over here. What is the main difference between mass and what is the main difference between weight? Okay, the mass of a body is a measure of inertia of body and hence called inertial mass. Inertia means what? Something force is there in a body to keep it in a motion or keep it at a rest. This is known as inertia, correct? Some force is going on or some force is exerted on a body which keeps the body at a rest or in a motion. This is known as inertia. So this inertia is known as mass. And mass is a scalar quantity, correct? It does not have any direction. When it has a direction, it will be a vector quantity. Now SI unit is kilogram, CGS unit is gram. Mass of body is constant and does not change from place to place. Wherever you go on the earth, you go on the Mars, you go on the moon, you go on the Jupiter, the mass is not going to change. Okay, the mass is measured by a beam or common balance. Mass of body cannot be zero. Okay, the mass of the body will always be greater than zero. Next we take is a weight. Weight of a body on the earth is a force with which it is attracted towards the center of the earth. Now mass was what? It was related to inertia, and weight is related to the force, that is gravitational force. Weight means what? Mass into acceleration due to gravity. It is W is equal to M into G. Sorry. What simple thing you have to remember, that is mass does not include gravitational force, but weight includes gravitational force. So SI unit of weight is Newton, and weight of 1 kg mass is 9.8 newtons. Weight is always measured in Newton. Okay, weight is a vector quantity because it has both magnitude and direction. Okay, weight changes from place to place. Okay, moon there will be more or less, then on the other planets the weight changes. The weight is measured by a spring balance. Okay, weight of a body can be zero when body is taken to center of the earth. The acceleration due to gravity at center is zero, hence the weight will also be zero. Why zero? Why everything depends on only the acceleration due to gravity? Because there is a multiplication sign over there. If gravitation becomes zero, everything will be zero. Okay, remember this. So greater means however close, how close you go to the earth's center, the weight will be more, and as far you go from the earth center, the weight will be low. Okay, on the moon, acceleration due to gravity is nearly 1/6 of that of earth, and hence the weight of the body on the moon is 1/6 of its weight on the earth. Okay, you have to keep in mind this give reason. Okay, so here we have completed the earth's gravitational constant, and what is difference between acceleration due to gravity and earth's gravitational constant. The value is 9.8 meter per second for the acceleration due to gravity. Then we have seen the free fall. Okay, so in the next video we are going to see this. We can see the two persons over here, that is Pascal and Archimedes. Okay, we are going to see what these two people have done. Okay, thank you students.